So it's mainly a presentation from my Swiss company, some of the team members working on this at Edelweiss Connect, but also some collaboration with ZIFO, our IT services partner within Silica, doing the work on BioBricks in the United States with Eric and Fairness, current ASPIS projects, Misconduct on-tox, precision tox, we're developing NGRA solutions. More recently, Safer by Design case studies on SSbD for chem, and some industry case study work. So obviously I won't be able to discuss everything, I'm just going to select a few things. So this is my outline. So on issues, so our goals are basically to try to prepare all the relevant data and knowledge we need to carry out risk assessments. And we want to put risk assessments into a structured practice so we get a more reliable result at the end of any risk assessment or the component of any risk assessment. Typically, it'll also be tiered, so you need to see what a particular tier or phase gives you as a result with an uncertainty and then go back and try to refine it. So it's typically a tiered phased IATA approach. And then when we get into Safer by Design, we try to extend it to other kinds of analysis you need to do. Open standards, like has been mentioned, are important, so we're also trying to leverage that aspect. Now, the main issues with regards to data is we have a lot of variability in quality over time, over practices, how well protocols are documented, maybe the way you look at a particular data set with a particular question and selection of metadata, you can get a very different answer. Same with literature. If you do a systematic review, you may actually reject most of the knowledge in the peer-reviewed literature and only take a small amount of it forward. A lot of valuable knowledge is in industry. Preparing fair data is very time consuming. So if we're thinking about business cases, we have to take into account the cost of preparing the data and the knowledge, as well as the return we get out of it. And if it's for maybe a project where we only do something once, well, maybe there isn't a good return of investment, right? So we need to think about the business case as well. We've been making progress, I think, on the acceptance of the importance of open standards and ontologies, but there's still plenty of work to do. And we have sort of new issues with AI. Is the whole world of the internet going to descend into a lot of rubbish knowledge that's increasingly generated by AI itself, what's now called AI junk, and you see it accelerated by politics and social media. And so how do we manage the increasing amount of knowledge which may or may not be true and really isn't knowledge? So we want to take like a scientific approach, define our use cases, our case studies, clearly define draft business cases, and then work through problem formulations and test out whether we can get to an answer, how much does it cost, then does having fair data or fair knowledge make a difference and have a business case. We're also doing a bit of a back to the future. A lot of what we talked about, primarily based on machine learning in the initial OpenTox framework paper 15 years ago, applies to today, but it needs to be updated. So, I mean, we didn't think about how to deal with hallucinations back then, so we need to do some updating. So we're working on that, and we'll present that as a 2.0 OpenTox framework paper at the virtual conference in November and publish it. I won't say any more about it here. And in our risk assessment test cases, we're trying to take fair data, but also other kinds of documentation. For example, the knowledge graph approach, where you link different kinds of knowledge in chemistry, biology, and other areas together, and see how they assist in carrying out the risk assessment workflows. And then especially how risk assessors get their work done. And they're mainly doing calculations and generating reports. they're not actually typically doing scientific analysis work. So we're trying to not just support the science needed in NAMs, but in the end, support the workflows risk assessors need to do. Okay, so now I'll just accelerate a little bit. One of the main programs where we're developing the next generation workflow approach is on Risk Hunter, and it's already been made an ASPIS cluster activity and opened up more. And the idea is to structure any combination of human risk assessment in the Risk Hunter case based on human assessment, exposure modeling, into a workflow for the different kinds of hazard and exposure analysis you need to do. And Risk Hunter is basically a project developing an IATA approach combining in vitro and in silico solutions with a lot of modeling to develop a framework for next generation risk assessment, the NGRA. So there's a lot of current case studies, and we build a knowledge infrastructure on compounds, on biological data, now putting fair biological data into knowledge graphs, and now increasingly, we've worked a lot on documenting the methods for fair data, but how do we document all the increasing amount of data coming from in silico protocols and models? That's an area we're working on currently. So for some models like QSARs, we've got some good sort of practices and frameworks, but other areas like QAOPs, it's pretty much an emerging area. Now, there are different sources of knowledge. So one is the work we have to put in to preparing data that's fair, time intensive. You need to design harmonized templates, and then you need to convince people to work with you to get all the metadata defined and into the system. So it's quite an intensive activity. And even when you work hard on it, you still find there's lots of little problems you have to curate. So this is clearly an area that has a business case for AI to help us in the overall knowledge infrastructure, which is, this is the one we just published in EU-ToxRisk. Actually, we got quite a few discussions going on the fairness aspect. A lot of the comments for improvement from that discussion we'd already been working on because we took it into the Risk Hunter project, and we'll be publishing on that soon. But at the end of the day, we need to have good metadata, have it harmonized, have all the methods well documented, and be very clear how are we deciding which data is going into which models we want to use in the risk assessment. So when we put data into a knowledge graph, we may be able to link chemistry on compounds with studies, the biological data generated in the studies, through to key events in the AOP wiki, for example, for a particular question, for a particular pathway. And do we have some ontology problems there? Do we have some curation problems? Yes. And so you have to try to work on polishing things. It takes quite a bit of time. So again, the AI can assist us in generating these kinds of graphs and checking on metadata. Another source of knowledge is from literature or documents. So this is an example from literature that ZIFO have built as a prototype that we want to process information from the literature using the AI assistance. Systematic review is very time intensive. If you do it manually, you may have to look at thousands of articles. So again, there's a clear business case here and an area where the language model technology can actually be quite helpful. Say, at least in doing 90% of the job, you still have to curate. And then, of course, what we want to use then, if we're working through a risk assessment workflow, and we have a question like, okay, now we have the problem formulation, what do we know about this compound? Then we could query then the language model and bring that into the documentation of that task and store it, have a memory of it too. This is a different kind of case, more in the the drug area where we're trying to combine in a framework omics, data from omics to create a model and look at what we get from literature. And are they, do they have a lot of conflicts often? Yes, they do. So the idea, again, is how can you use different approaches to combine different sources of evidence and test different filtered views on your current graph for the knowledge and test it with experiments, but also increasingly with computations, so you can do simulations to test maybe key events in your graph. Then one final example. This is more in the sort of business area. This is our new software, which is about organizing product information, and the there you need to potentially organize information on thousands of ingredients and tens of thousands of formulations. So processing the historical information from documents into the system can be quite time consuming. So there's a business case there. Maybe the knowledge mining AI can help you get 90% of the job done. And then you have to put in an additional 10% of time with human curation, but it's a clear case. But if you only have to do it once, then that's also a factor too. Of course, the other case is on generating reports. If there's any change in information, in the literature, in a regulation, you have everything well organized so you can generate the report. Again, you can use generative AI for that, but you still need the risk assessor maybe to go in and say, okay, now I have 200 reports with a new variation. I still have to check it at my interpretation, sign off, and submit. So again, a human AI collaboration. Practices on standards. I had to look for this for quite a while at breakfast because I haven't used it for a long time. But it's a very old slide from 15 years ago when we had the first OpenTox framework, which you can see a lot of what we're talking about here today, having interoperability, having well-defined metadata, being able to exchange it between resources and programs, being able to have metadata aligned with ontologies, build models, integrate information and validate models with an applicability domain. So a lot of it was already there. So we're revisiting that and try to discuss some of the issues on what influences it has had in the last 10, 15 years, what has progressed, what do we need to do, or how do we extend it to some of the new AI. Another thing we work on it's now available as an open science resource for you to try is based on this paper from 2019 on ToxTemp, where you really document your test method, and it is tiered, and you can do it at different levels, and it also now has a review process, so it can also be reviewed. And the idea with the integrity of this is any experimental data in the system should always be linked to a ToxTemp-based method documentation, and then the equivalent in the in silico area. Just briefly, workflows. So under Risk Hunter and ASPIS, we're trying to develop different workflows to bring this information together. It's a high-level workflow. So it's documenting the work you're doing in any particular task or decision to get to the final conclusion, perhaps in this iteration, and have everything documented. And you may iterate again and refine it and reduce your uncertainty. And what you see we're doing here is extending that to safer and sustainable by design and testing that with different case studies. So currently we're doing cosmetics, car industry, and textiles. And you have to do not just the human and environmental assessment, but you also have to look at sustainability, life cycle analysis, recycling, end of life cycles. So it's this broader framework that's being currently tested out. And the assumption by European policymakers thinking about Green Deal is the current system just not going to work for the policy goals, and we need a new approach. So we're just trying to look at how could NAMS-based NGRA be extensible to other kinds of tasks. And you still have to bring data and knowledge into them. So this is just showing one that's dealing with the first step, which is hazard characterization. And the idea is you should start with as many options for your product as possible, not just compounds. I mean, it could be advanced materials, polymers, and so forth. And then you gradually reduce the best options, but you try to take everything into account. So you do all the steps in parallel and you look at how you can optimize your product. So just last couple of things quickly. Making models fair is another area we're looking at, and Mark Cronin has been writing on that and is working with us on this model repository that we work on how to make models fair. There's a number of topics we have to address there, and of course data from in silico models. We've also favored a lot this Bayesian network approach because you really put then a quantitative model on different weights of evidence that we need to use in these workflows. And this is from recent work we did with Beiersdorf. And you can use incomplete information, and you can really quantify the weights on the different sources of evidence, and you can also compare the results. So I think Bayesian networks are going to be a very important part of our AI in the years to come, especially in risk assessment. Legal and ethics, I mean, we could spend the whole day talking about this, just that we're paying attention to that, on how we're going about this fairness and these workflows, and hopefully we'll talk about that another time. But we're looking at current legislation in Europe and US, and it's different, and some of the concerns maybe in misuse of this knowledge that we have to protect against. And then finally, I'll finish with an example. So in the area of characterization of advanced materials, in this case functionalized graphene, images, experiments generating images are a very important part of the work, and a lot of different kinds of experiments are done. So what we did here is try to build a knowledge infrastructure to extend to images, and also use, again, we try to use open things as much as possible. So in this one, we aligned with an open standard for images, the RAMBI standard, which mainly comes from biology. And one problem you immediately run into there is, I mean, there's no adopted open standard on images across vendors. I mean, there's all sorts of formats. So we've tried to put into the workflow, we convert all the images from the different experiments into more standardized open XML format, which would be closer to, say, having a semantic description of the images. And then we can put the images into the deep learning, and that's something AI does well, and can characterize size and shape, of what's on the surface of the graphene material. Okay, finally, outlook. So recently we put in a case study process so that a company, including with confidential data, could engage with us on such a case study, and could include confidential data, but also have a mechanism, say, to share the knowledge back that can be shared, maybe not with the confidential data, back into a community of practice kind of forum like we have here. And we started the first couple of these case studies working on quite difficult problems, I would say. And this is open, so if you want to get involved, talk to me later. And some of that will be trying to address some of these difficult problems when we have a case study and you bring in all this knowledge together, and some of it is fair and some of it we try to make more fair, but we still have a lot of conflicting evidence, it seems. So how do you tackle that? So how do you have views on what we currently have in data and knowledge, and then test it out against a case study with such a workflow, and then figure out where the uncertainties are, and then go again and improve it until we're convinced we have a clear answer. So that's where we are. Thanks for the time.
Thank